And finally number 4, square root of 500 divided by square root of 5. This is square root and that is square root, therefore you can divide these numbers. 500 divided by 5 gives you 100, you see. 500 divided by 5 gives you 100. And square root of 100 is 10. So that's the answers for number 1, 2, 3 and 4. And I hope you got 4 out of 4. If you've done that, well done. And we're going to move on to lesson number 4 on surds. Next we're going to do lesson number 4 on surds. If you didn't succeed, please go back, find your mistakes, redo the examples, and in every exercise you must get full marks because these are only the basics. Alright, we're going to move on to lesson 4. Okay, we're in lesson 4 now, and we're going to learn to rewrite surds as powers. For example, if you had a square root of 18, square root of 18, that is in a surd form. Now you want to rewrite this as a power. Now what you must understand is the index 1 is understood here. Right? The index 1 is understood. Now you can write it down. And what you must also understand that the number 2 is understood here. So you can also write it down. Okay. So now you can rewrite that as a power. Right? So it becomes 18 to the index half. So a replacement for a square root sign is a half. So this becomes 18 to the index half. Right? We take this 2 and we make it a denominator. Right? Let's do another example. Suppose we had cube root of, for example, cube root of 24. Say cube root of 24. Now the 3 is there. But we must remember that the 1 is understood and we can write it. Now once again, this 3 will become the denominator. So it will become 24 to the 1/3. Right? So if you're using computers, remember this is a superscript. Right? 1/3 is a superscript. So that's how you rewrite surds into powers. Now let's take another example. Suppose you had cube root of 2 to the 5. Let's say you had cube root of 2 to the 5. Then once again this 3 will become the denominator and it will become 2 to the 5/3. Let's do another example. Suppose you had some letters now. Say you had A root of m to the n. Then by the same principle, the A will become the denominator. So it will become m n all over A. Of course, you will say that A is not equal to 0 because A represents any number and it cannot be equal to 0. So that's how you convert a power and a surd into a power. Right? So let's give you a little exercise to practice that. Alright, here's an exercise where you have to rewrite each surd as a power. Number 1, square root of 18. Number 2, square root of 48. Number 3, square root of 500. Number 4, cube root of 24. Number 5, cube root of 54. Number 6, cube root of 500. Number 7, cube root of m to the index a. And number 8, square root of x to the index y. Alright, what you will do is take them down, stop the DVD, rewrite them as powers, and then come back to us and we will mark the exercise for you. Alright? So stop the DVD, take them down and work them out. Alright, so when we look at number 1, we've got to understand that there's a 2 here that's understood and there's a 1 there that's understood, and therefore if that goes there we have 18 to the half. Once again, there's a 2 understood here, there's a 1 understood here, therefore the answer is 48 to the half. Once again, there's a 2 understood there, 1 understood there, the answer is 500 to the half. Now, this is cube root, so 3 is already written there, and what is understood here is 1. So this one is 24 to the 1/3. Next one, number 5, this is cube root. Well, the cube root is understood, and that's 54. So what is understood there is 1. So it's 54 to the 1/3. Cube root of 500, once again, the 3 is there, but the 1 is understood. So this is 500 to the 1/3. Now, there's an A here, so this 3 becomes a denominator. So there's the M, which is the base, there's the A here, and the 3 becomes the denominator. Right? And finally, in the last one, it is square root. Therefore, the number understood here is 2, and the 2 becomes the denominator. So the base is x, and the index is y over 2. Right? So that was converting surds into powers. Alright, and I hope you did well there. Okay, we're moving on to lesson 5, and in lesson 5 we learn how to rationalize the denominator. So let's take an example. Let's take examples where we have to rationalize the denominator. Well, firstly, even before we do an example, let us understand something. Let's just put an example on the board. Suppose I gave you 2 over square root of 5. Now that is a rational number. And this is an irrational number. So rational number means it can be written as A over B, right? B is not equal to 0. In other words, it can be a fraction. It can be written as a fraction. It can be written as a fraction. Right? So it's A over B, and B is not equal to 0, and these are any 2 integers. Right? A and B are any 2 integers. Or to put it simply, a rational number is a number which can be written as a common fraction. For example, 2 is 2 over 1. But this one, square root of 5, is an irrational number. Right? You cannot find the square root exactly. You cannot find the square root of 5 exactly. That's why it's called irrational number. Right? So now, we do an example. So the denominator is irrational. You want to rationalize the denominator, means you want to make it rational. So let's do some examples and see how it's done. Number 1. Suppose I gave you 1 over square root of 5. Now this is irrational. You want to rationalize it. So all you do is you multiply. You look at the denominator. The denominator is square root of 5. So you multiply by square root of 5 over square root of 5. So what you're doing, you're multiplying this by 1. Square root of 5 divided by square root of 5, you're multiplying it by 1 really. So you're not changing its value. So the secret is, look at the denominator and then multiply square root of 5 over square root of 5. Now, 1 times square root of 5 is square root of 5. In the bottom here, we got square root of 5 times square root of 5, which becomes square root of 5 times 5, which becomes square root of 5 over square root of 25, which is 5 square root of 5 over 5, because the square root of 25 is 5. So, let's go through that method again. We were given 1 over square root of 5. Because the denominator is square root of 5, we multiply by square root of 5 over square root of 5. 1 times square root of 5 is square root of 5. Square root of 5 times square root of 5 is really the square root of 5 times 5. I've written it down. The numerator is still square root of 5. Square root of 5 times 5 is really square root of 25. That remains the same, but square root of 25 is 5. Now you can see that the denominator, which was irrational, has now become rational. This was irrational. And it now has become rational. That is why we say rationalize the denominator. Alright, let's do another example. Square root of 3 over square root of 7. Right. So, once again you look at the denominator and you multiply by denominator upon denominator, which means square root of 7 over square root of 7. Right. Now you've got that. You look at the denominator, don't worry about the numerator. Although the numerator is irrational, don't worry about it. You only look at the denominator. Square root of 7, multiply by square root of 7 over square root of 7. Now, on the top, you got square root of 3 times square root of 7, which will become square root of 21. In the bottom, you got square root of 7 times square root of 7, so it will become square root of 7 times 7. The numerator is 21. This is square root of 49. On the top, you got square root of 21. Square root of 49 is 7. So, you have now changed an irrational denominator into a rational. Right, now let's do another example. 3 over square root of 2 plus square root of 3. Alright, let me start this on a fresh page because it needs more space. Alright, so in this case, you multiply by 5 over 5. In this case, you multiply by 7 over 7. I'll do this on a fresh page as we need much more place. Alright, we're doing number 3. Now, don't worry about what I wrote before. We're doing this example here. Suppose we had 5. So this is number 3, alright? Don't worry about whatever you saw before. 5 over square root of 2 plus square root of 3. Now the denominator is irrational. Once again, you look at the denominator and you multiply. But this time, you have to be a little careful. You put, you see here, it is 2 plus root 3. So there, you must put 2 minus root 3. Okay? Because we're trying to create what is called a difference of 2 squares. Alright? We're trying to create a difference of 2 squares. Alright, so in the numerator, we got 5 times square root of 2 minus square root of 3, which we could leave like that. That's what the numerator is. 5 times square root of 2 minus square root of 3, we put that in a bracket. But in the denominator, we have square root of 2 plus square root of 3 times that, which is square root of 2 minus square root of 3. Now this is like a plus b into a minus b. It's like that. And if we did that, we would have said the answer is a squared minus b squared. A plus b into a minus b is a squared minus b squared. So, therefore, the numerator will be 5 into square root of 2 minus square root of 3 all over. A squared, this is a. So it will be square root of 2 all squared minus, this is b, square root of 3 all squared. Because this is a plus b into a minus b. So it will be a squared minus b squared. Now that's 5 into square root of 2 minus square root of 3 all over. Now, square root of 5 squared, this one, or square root of 2 squared, this one. Square root of 2 squared means square root of 2 times square root of 2. Square root of 2 times square root of 2 really means square root of 4. Square root of 4 is 2. Therefore, instead of doing all this working, we can come to a conclusion that square root of 2 squared is 2. And therefore, square root of 3 squared, instead of me doing all that working, just like how that one works out to be 2, this one will work out to be 3. Well, maybe you don't trust me. Well, let's see. It's square root of 3 times square root of 3. It will become square root of 9, which becomes 3. So, square root of 2 squared is 2. Square root of 3 squared is 3. So, square root of 2 squared, we worked it out there, it's 2. Square root of 3 squared, we worked it out there, is 3. So finally this answer is 5 into square root of 2 minus square root of 3 all over minus 1. Now this minus 1 can multiply with this 5 here, and it will be minus 5 into square root of 2 minus square root of 3. Remember, 5 over minus 1 is the same as minus 5 over 1, which is the same as minus 5. 5 over minus 1 is the same as minus 5 over 1. It's the same as minus 5. So 5 over minus 1 would be minus 5. Alright? So that's rationalizing a denominator where you got more than 1/3 in the denominator. Remember, if it's 2 plus root 3, you multiply by 2 minus root 3 over 2 minus root 3. Right. I'm going to do one more example like this. Right. And then we'll give you an exercise. Alright, so we're going to rationalize the denominator in number 4, where we've got the question 4 over square root of 8 minus square root of 5. So if we have to rationalize this, then we'll have to multiply by square root of 8. Remember, here it's minus, therefore there it will be plus. Right? Remember, here it was minus, therefore on that side it will be plus over plus. Remember, this is 1, therefore we're multiplying this whole thing by 1. We're not making any change to it. Right. So in the numerator we'll have 4 into square root of 8 plus square root of 5. You can leave that just like that. In the denominator we're going to have square root of 8 minus square root of 5 multiplied by square root of 8 plus square root of 5. Alright, now that gives us 4 into square root of 8 plus square root of 5 all over. Right, again, this is like a minus b into a plus b, which is a squared minus b squared. So, this will be square root of 8 squared minus square root of 5 squared. So, in the numerator you got 4 square root of 8 plus square root of 5 all over. Now square root of 8 squared. Square root of 8 squared. You can even try this on your calculator and you'll see you'll get the answer 8. Square root of 5 squared. And you'll see you will get 5. And so the numerator will be 4 into square root of 8 plus square root of 5 all over. 8 minus 5 will give you 3. And that will be the end. Because that's 4 and 3, it won't simplify anymore. So that's rationalizing the denominator. The denominator is now 3, it's rational. Alright, so that's called rationalizing the denominator, and we'll give you a little exercise to try hereafter. Alright, so here's exercise 5, and you have to rationalize the denominator. I haven't written the question down, sorry. Rationalize the denominator in each example. So rationalize the denominator in each example. Alright, so you can stop the DVD after I have finished and try it. Okay, so the first example is 1 over square root of 5. Number 2, square root of 7 over square root of 8. Number 3, 5 over square root of 5 plus square root of 7. And number 4, 4 over square root of 3 minus square root of 5. Alright, you can stop the DVD, try these examples, and then come back to us and we'll mark them for you. Yes, welcome back. And if you're scoring 11 out of 10, it's very good. Right, let's do number 1. Number 1 is straightforward. You're going to multiply by square root of 5 over square root of 5. And so the numerator will become 1 times square root of 5, which is 1 root 5. Well, actually, there's no need for me to write the 1, 2. But anyway, I'll write it down. 1 root 5. 1 times square root of 5 is 1 root 5. Over. Square root of 5 times square root of 5 is actually square root, alright, of 5 times 5. That gives you root 5. I don't have to write the 1 because it's root 5. And this is really square root of 25, which is really square root of 5 over 5. So, it may look very funny, but it is correct and it is true. 1 over root 5 is actually equal to root 5